Today we are going to discuss a DP problem uh, on coding ninjas. Okay, the question is count the ways to reach the nth step. So the question goes like this: you have been given a number of stairs. Initially, you are at zeroth stair and you need to reach the nth stair. Each time you can either climb one step or two step. You are supposed to return the number of distinct way to reach to which you can climb from zeroth step to nth step. So the test case they have given is n is for n is equal to 3, output is 3. So let me explain you what this problem says. So we are given a stairs, right? We are given stairs. So you are imagine this is a zeroth index, and you need to reach your at zeroth index, and you need to reach the destination index, right? Destination index. What you can do is you can take either one step, that means you can take one step, or you can take two step at a time, like that you can take, and you need to return how many number of ways that you can do that problem. So how to approach this problem? Actually, when they give these types of question like find the number of ways, find all possible combination like this they give, that means you should if imagine like can you solve this problem by using for loop? Actually you can, actually by using tabulation technique in DP you can, but normally you can't solve this you can't find number of ways by using without using recursion. So you need to think like this when there is a question like find the number of ways. So when there are lots of probabilities to take, so at that time we need to use recursion. And here what the brute approach I am applying is very simple. So you they in the test case they have given n is equal to 3, that means till third index we need to reach. That means what I consider is I will stand here, so I need to move here. So what is the possible ways that I can reach here? So I can take one step down or I can take two step down. So what is the possible ways? So I will consider that because if you are here and if you want to reach here, the number of ways will remain same, right? Whether you start from here and reach to the destination, or you start from the destination and you reach the zeroth index, the number of ways will remain same, right? So I will consider that actually you can do either like this, but let me do by considering that I am standing at destination, I need to go to zeroth index, so I need to find the number of ways. So what you can do, is you can take one step down or you can take two step down. So you can take one step down, either you can take two step down, right? So for n is equal to 3 it is so much easy, means uh, like we can find, right? From 3 I am going to 1, from 3 I am going to from 3 I am going to I'm going to 2, then from 2 I'm reaching 1, then to 0. This is first way. What is the second way? Second way I'm from 3 I'm going to 1, then I'm reaching 0, that is my second way. And third way is from 3 I'm going to 2, then I'm reaching 0. So for n is equal to 3 normally you can do, right? There are three number of ways, and that is what they are described in their test cases, in their test case. So what you can do is you can reach here first, then you reach here, then you reach here. That is my first way. Or else what you do is you reach here, then directly you jump here. Or you can reach here, sorry, you can reach here, then you can take you can go to zeroth index. So let me first write what would be my base case if n is equal to 0, or if n is equal to 1, what I need to return? It is simple, we need to return 1, right? We need to return 1, means imagine n is equal to 1 they have given. That means what you have is you have only one stair, you are at zeroth index, then you need to reach this first index. So if you are here, there is only one number of ways, that is you need to jump here. That's it. What if n is equal to 0? That means the starting position and the ending position is same. Starting position and destination is same. So what you need to do is you need to simply stand here. So there is one way, that is you simply stand there. So that is my one of my way. So I will return 1 when that is true. Then I need to write the other cases, right? So I will take like int, I will take like a is equal to, I will call the function, that is it is a recursive function. So since it is it is a function, I will write the function. So what function should return? It should return me number of base, right? So int function, and it will take n as the input, then it will check this one, and then for a I am pushing n minus 1. That means I am calling the nth, because my there are my conditions, right? Like I can go one step down, I mean one step up, or I can go two step up. So I need to take these two things. So a is equal to n function of n minus 1, then b, let me take b is equal to function of, this is so much logical to think like this, right? After that, what I need to do, I need to find all number of ways. So I will simply return a plus b. That's it. That is what my code will be. And for this, I am going to add dp. dp I have already explained you in first video, that is Fibonacci series. I have explained how dp works, that is how memorization takes place. Even here, what I am going to do is I will explain you. But if you need to see the dp, that memorization and Fibonacci series, you can go to playlist of dynamic programming. So now let us go to the question and let us type in the code. So what I return is, I will return a function. So that function I will pass here stairs. Okay. Then here I will write the function. That function is, it should return int, then function of n, right? Int n. Then if n is equal to 0, or else n is equal to 1, you need to return me 1. Or else what you do is, int a is equal to, you do function of n minus 1. And this one I am going to explain you in by using tree also, that is by drawing the recursive tree. So let me type in the problem first, code first, then let us see whether it works or not. So a plus b, so I am returning the value. Okay, then it should work, but it should give TLE, that is time limit exceeded. So we are getting time limit exceeded because we have not used dp. Now let me write the before going to dp, let me write the recursive tree, how it is actually working. See, if you see the code, you should be aware that this code you will be definitely seen, right? You will be seeing this code because this is Fibonacci series. That's it. That is what the same code I am simply writing here. But here for Fibonacci series, the first element is 0. But here the first element is also 1. That is what the difference, what I can tell. So let me write the recursive tree for this. So let us copy this thing and I will paste here. Okay, now again let me give n is equal to, let me take it as 3 again. So function of 3. So what will happen? It will come here. So this will be not satisfied. So it will not return anything. So it will go here. Then function of n minus 1 will be called. That is function of 2 will be called. Okay. Again immediately that will go. The control moves here, and again it will come here. Then again it fails. Then again it will call for n minus 1. So we are going to get f of 1. So immediately it will go back and it will check for if n is equal to 1, and this statement will be satisfied. So this will be executed and it returns 1. Okay, it will return 1. So when we, as you know, that recursion, how it works, whenever you will get the 1, right, whenever you will get the return, when you will get the result for any function call, right, then you should move to the next line, right, you should move to the next line. But you should know that when you move to the this one will be returned here, right, it will be returned here. Okay, here n is equal to 2, still n is equal to 2, right, n is not equal to 3 because I am in recursion. When I go down the recursive tree, after that I should, by step I should come, like like this we should come back. We should not go directly to n. That is why we write recursive tree, just to get the idea how it works. Because so how recursion will work, it will work like a stack, right? Stack, see, whenever I will call, I will first call will be made here, then second call will be made, third call will be made, and when you return the third call, value will be returned first, then second call return will be next, like that. It internally stack will be used for this. So similarly you should go from 1, you return 1, right? Now you should return for 2, but for 2 you have executed, let me rub this one. For 2 you have executed only first line still, right? You have executed n minus, for a function of 1, that is the only first line. Now you need to execute second line. Second line is n minus 2. Function of 2 will give us function of 0. Okay, now function of 0 again immediately will be called, and it will return 1 for us, and I will return this 1 here. And next, then function call for 2, both it will be returned for this line, right? Now we need to jump for this line, but still remember that n is equal to 2, still n is equal to 2. So a plus b you need to just add this one, 1 plus 1 will be 2. Okay, now you will get this result. Now the control will move back to n is equal to 3. Then again here for n is equal to 3 you have executed only this line, but not the second line, right? It is not yet executed. So when you executed this line, that is when this all left side tree is formed. So it is not actually the complete recursion what you have done. Now you need to go for second line. Second line calls for what? N minus 2. It is function of 1. So what will function of 1 will return? Function of 1 will return u1. So 1 will be sent here. So for n is equal to 3 we will reach the third line. So we need to add this 2 and 1. So when we add, we are going to get 3. That is what our result is. So for f is equal to 5, if we do, how it looks like is, again, it is so much simple. Let me directly draw this. I think you have got the idea. Actually f of 3 will be not executed directly, but while writing I will write like that, because I know that is how it works. So I will write 3 here. Function of this is 2, then function of, again, f of 2 will be called, then function of 1, then again function of f of 1 will be called, and again f of 0 will be called, and this all thing is nothing but addition you need to do. So you will do addition like this. Okay, now see, if you observe this one, it will return 1, right? It will return 1. It will return 1. So 1 plus 1, 2. 2 will come here. So it will return what? It will return 1. So 1 will come here. Then you will get 3 here. So you got 3 here. Now you need to execute this one, right? You need to execute this one. But if we have common sense, then what I do is, I already know for f of 2. For f of 2, the result is 2, right? Why I need to call these two things again? I can directly write 2 here, right? I can do that one. In coding I will do that one. Like by using dp vector, I'm going to do directly, I will memorize, because see how it works is, I will create a vector or an array, you can take anything. I will fill it with -1 initially. So I will fill it with -1. So for again, for n is equal to 2, that means for n is equal to 2 means this is 0, this is 1, this is 2. For n is equal to 2, I will store 2 as a result. Then whenever I need to call for f of 2 has to be called, then I will return this value, right? This value I will return instead of calling again. So again, this in a broader way, let me explain you again. For f of 3 I got 3, so I will store for f of 3, I will store the result as 3. So when I store it as 3, why you will call it again here? Why you will make 100 of call again? So you can directly write 3 here, right? So that is how it works. So in coding part I am going to show you. Now I need to create vector, right? Vector, it is a vector int, and this is a dp, and in value they have given as 1000, 10 power of 5. So 1 2 3 4 5, then I will fill it with -1. Then I don't need to return, since it is a global variable I can use it directly. So sorry for the disturbance, but yeah. Then I have created a vector. Now what I need to do is I need to return if that vector dp of n, if it is not equal to -1, then what you do, you return me, instead of calling 100 times, you just return me the dp of n, right? While when you get the result, what you need to do is fill the vector. So I will add this line. So just adding this line, I added this line, then I added these two lines, then I added this line. So three statement that you need to add, and it will work. Now I will run. I should get the result, but I am not getting. Let me see for which statement. Okay, I think whether I need to return, and while returning I should take the reminder, I think, right? Let me do that one. I will take for int n is equal to, I will give it as 1 2 3 4 1 2 3 4 7. Okay, next what I do is, while returning I will simply take the reminder of n. I will return that thing. So I think it should work. Okay, everything is working. So let me submit, and we should get the, yeah, now we have got the result. So this is how it works, and further I am going to I'm going to post lots of video on dynamic programming. You can check out this playlist, and please subscribe to this channel, and thank you.